why Total Precast should be your next building system. So present today will be myself, Jason Stubby, and Sean Bickel. So Sean's been with us since about 2012 at Stubby's Precast. He's a grad of Mohawk College. Sorry, should be Conestoga, but no. And he's basically started in the estimating team, putting together the proposals, and then he helped spearhead moving from hollow core only production into total precast buildings. Myself, I've been with the company for a couple of years. Didn't go to school, just went to the school of hard knocks. Started more in the construction end of things, basically building buildings on site, then ended up taking care of the construction side, and then now I've moved into sales manager. So I'm going to warn you, we're far from professional speakers, but we'll try to do our best. Stubby's Precast, who are we and what do we do? So Stubby's Precast, we started in 1982, so last year was our 35th anniversary. We started more in the precast agricultural products. So my grandpa at the time designed a precast pig feeder at the time because they were all steel. The steel ones used to rot out all the time from the pigs using them. So we designed a precast feeder and started shipping them all over Ontario and started shipping them down into the US as well. From there, we moved into agricultural slatted floors. So we do slatted floors in dairy barns, hog barns, bunker silo walls for storage of feed, that type of stuff. Now, we still do all those products today other than the pig feeders. The pig feeders have been replaced by stainless steel since then, but we still do the rest of the agricultural products. And they have grown as well. It's just our commercial side has grown a lot more than the agricultural side. So in 2001, we got into hollow core floors. So we originally got into hollow core floors to build chicken barns. We did one chicken barn and haven't done a chicken barn since, but we have done a lot of commercial buildings. So we do old age homes, apartment buildings, garage floors on residences. Basically anywhere you could have a second story or a roof, we've been doing hollow core floors. In 2006, we built another plant, Plant 2. Plant 2 was built for precast wall panel production. So we already had Plant 1, which had the agricultural products and the hollow core floors. And then in Plant 2, we started doing a lot more precast wall panels with the end goal of eventually be able to build total precast buildings. So up to date, we've done 40 total precast buildings, mostly on the outskirts of the GTA. We've done one in the GTA, but most of the stuff, because we're non-union, has been on the outside of the GTA. Kitchener-Waterloo, London, Barrie, Hamilton, that area. So what is total precast? So total precast is basically us supplying the entire structure on site. So we supply precast wall panels. We manufacture them at our quality controlled environment. Everything's produced indoors for these buildings at our shop. We put them in the yard, we load them up on trucks and deliver them to site. Once they arrive on site, our own erection crews basically erect the wall panels. We put the hollow core floors on top, and then the next level of wall panels. All the products we're a conventional reinforced, so rebar reinforced products, as well as pre-tensioned. So we use pre-tension wire in our hollow core floors, as well as some of our cladding walls. So a lot of flexibility that way as well. So one of our biggest advantages is speed. So the number one reason people, I would say, switch to doing total precast construction is the speed of erection. We can do an exterior wall, interior walls, and hollow core floor, so the whole package, 8,000 square feet of floor plate in just 5 working days. We just did a hotel, so that's what we kind of run with. We're usually a touch faster than that. We just did a hotel in Brantford. I don't know if anybody's from the Brantford area, but there's a new Home 2 that went up. The Home 2 is, I think it's 9,000 square feet per floor. It's 6 floors, including a precast roof. We were able to build that hotel in 30 working days. So in 6 weeks, the entire structure was up. The exterior was done, other than the caulking and the coating. Interior load-bearing walls, all the structural components, basically ready for your interior finishing trade, steel stud, electrical, mechanical, etc. Along with the package, we do precast stairs and landings as well, so you have access to every floor as we're kind of going up the building. So everything we do is produced, so I should say, so we actually built Plant 2 in 2006, but we've since completed Plant 3 in 2016-ish?
Yeah, 2016, yeah.
So 2016, we completed Plant 3. Plant 3 is the most automated and up-to-date plant in North America for precast production. So we built it in 2015 to 2016, and it's geared solely to start producing more precast wall panels to go into the total precast market. So this picture here is a picture inside of Plant 3. Everything we do is produced, we're a CBCI certified plant, so everything goes through a pre-pour and a post-pour inspection to make sure that everything we do is at a high quality standard. And then we get audited every 3 to 4 months to make sure that, yes, they are using 6,000 PSI concrete. We test each mix daily. The rebar was being put in correctly as per the engineer's specs, etc. Another one of our advantages is all-weather installation. So we really don't get shut down for anything other than wind. So we got grout where we can set walls up to about -20. So snow doesn't really bother us. Actually, our busiest time of year is actually September to March, believe it or not, in the construction industry. A lot of guys dig their holes, get their permits and stuff in the spring, put their foundations in the summer, just in time for the snow to hit and stubbies to show up and start working in the cold. But because of the beauty of the system, we do require some winter heat to grout the hollow core floors, but turn it on for 2 days and turn it back off. Wind does slow us down, just like every other crane that you have on site. It's really the crane that slows us down. We can go up to about 40 kilometers an hour, 50 kilometers, just like every other crane. So with this, we consider ourselves a structural precaster first and an architectural precaster second. So these buildings, our ultimate goal is to build the structure for you, but one of the biggest benefits is you're getting an exterior finish along with that structure. So we'll go through some of the different finishes we have here. This would be what we call flat panels. So we just use simple reveal lines, so half by half reveal, and we change colors. We put in patterns with reveals. If you actually head over to our booth at 5012, you'll see some of those different patterns that we use. Very cheap and economical, probably the cheapest finish we have. And it'll come in either a sand texture, so something similar to... So this one here is our smooth texture. So it's basically, we use 2 different products. We'll use a BASF coating that goes on. It's called HB300. That's the smooth product, or we can add sand into that same product and gives you basically that stucco look almost. We've recently started working with Kime stain as well. The beauty of the Kime stain is that we can actually do the first coat in our shop. So with Kime stain, we actually do 1 coat of coating in our shop as it's coming off the line. So your panels are pre-finished coming to site. Once the building's erected, we caulk it, and then we come down and do the second coating of paint on site, or stain. With BASF product, we need to let the concrete cure longer. So now we need to let that concrete cure for 14 to 15 days. But just due to our manufacturing process, it doesn't actually work. So we have to do everything on site. So if you're using the BASF product, we ship the panels just a natural gray, and then we do the coating on site. Here's some of the different mold liners that we can do. This here is like a brick finish, and then all we do with that brick finish is we take a roller and we put the coating over top of the face of the brick and leave the mortar joints gray. So that's kind of what you're seeing in that picture. This is actually at our plant. Keystones like this around the windows, very easy for us to do. Just simple reveal lines to actually get you those patterns around the windows. The mold liner, there is a bit of cost to the mold liner. On the average, you're $5 to $7 a square foot, depending on the type of mold liner you pick. But still a lot cheaper than having to brick the building afterwards. Plus, you have all the schedule advantages. Right? So there's some brick, some ashlar stone look, and this is at a Holiday Inn in Niagara-on-the-Lake. It's more of a cultured stone look. Just some close-up shots. And form liners, we can pretty much do any form liner you want. We've got form liners for fluted, wood grain, all different kinds of stone patterns, brick patterns, etc. It's really what the architect or the owner would like to see on their building. So that's the brick. That's a fluted. These 3 would probably be our most common. We'll do fluted, but fluted usually people do more as like accent fans or just dress up the building instead of actually on whole elevation. Another thing with the mold liner is a lot of guys will, just to dress up the podium of the building, will do the mold liner on the bottom 1 to 3 stories to kind of give that podium a look, and then they'll switch to the cheaper painted or stained finish above, just so that you're getting the benefit from the street view, but you're not paying for that expensive finish all the way up the building. or they'll just do strips. So they'll say, okay, well, let's take that strip of stone and just run all the way up the building in a 4-foot strip all the way up the building and dress it up that way. So this is that same mold liner, but we've put a different finish to it. So instead of actually using the Kime stain or the BSF coating, we've actually used knockoff and done a multi-tonal stain. So what they do is they go along, they hit it all with a base color, and then they accent different stones to be different colors. They can do some really amazing stuff with this. We just recently built a new office, and we've probably got 15 different walls and different tones and different ways they can dress it up. Really amazing. In our booth, we've got some wood pattern stuff that you can see. It actually looks like real wood, but when they use the different colors to get that look to it. But it's got the durability of the concrete. So this is you kind of see the wood grain finish here. And then that's some of the finishes that we use in our office building. So that's, again, another wood pattern, kind of like a rustic stone. So here we actually coated the joints of the mortar as well, just to kind of get it to blend in. It is a bit of an upcharge to get this multi-tonal stain, probably $1 to $2 a square foot, but definitely, if that's something you're interested in, something to look at for sure. Now we don't do, so this is white cement. So we just recently started doing white cement. Up till now, we've just done it on general tender jobs. So we'll do it on like cladding on a Walmart or that type of stuff. We haven't done it in total precast. There's a lot of work to keep the white clean as you're building. But it is a new finish that we are offering. So if you don't like the idea of a coating or something on your product, we can actually give you white cement, and we can give you the white cement in a variety of different finishes. So like an exposed aggregate, a acid wash, a medium sandblast, a light sandblast, etc. And then this we could do in any of the walls, but we basically cut out styrofoam and lay it in, and then we pour over top of that styrofoam, and we get your logo put in the wall. Building number is pretty common. Most of our buildings, we end up putting the building number in the wall or in a sign form. But very easy for us to do and not very expensive. So just a neat little detail. So this is actually our new office on our property. So we're located in between Woodstock and Brantford, and about 5 minutes south, in the middle of 2 cornfields and a bean field. So we kind of stick out. So what we've done is said, okay, if we were building our own building, what would we want? So we said, well, we want to bring as much of the trades together into one scope as we can. So with our buildings, we always provide exterior caulking so that you're getting the rain screen and the weather details from us, so you're not relying on a precaster and a caulking guy and potential conflict that way. It's all done under us. At the end of the day, it's our name on these buildings too, so we want to make sure the details are done properly. So it's one of the reasons we brought this in-house. Any of the miscellaneous metal as you go up the building, so in your hallways, corridors, that type of thing, you're going to have angles that run across your hallways. We'll supply that as part of our package. So we're also a CWB certified shop. So we produce all these steel lintels and beams in-house, and we basically ship them to site and put that together with the package. Any core holes through the floor for sprinkler, electrical, mechanical, that type of stuff. Anything 6-inch or bigger, we'll pre-notch at the shop, so you have to get your mechanical guy to mark them up on the drawings, and then we'll actually notch them at the shop. Anything 2 to 6-inch round, we'll drill on site for you. So we have separate guys that come along afterwards and do that. And they work pretty closely with your plumbers to make sure we can do it. Now so there's pre-tension wire in the hollow core floors. We can only cut 1 strand per slab. So sometimes you get your shower and your toilet to govern, and then the other holes you might have to slightly adjust to miss a strand. But usually within a wall chase, so it's fairly easy to do that. This one we're very excited about. So we've recently started installing windows in the precast as well. So at our factory, we've started to install the windows. We actually have our first job coming up in January, hopefully, where we're shipping it out. So we've done this piece as a test piece. We're hoping to do this job just to make sure everything worked out the details. One of our biggest fears is the window going to break going down the road? We've talked to other precasters in Europe that do the same type of thing. That was their big concern, but they haven't had one break yet. So we might be worrying for no reason, but we kind of want to get this project out of the way and then start to offer it full time.
Who's the window?
This window is Norstar. It's an aluminum window. Norstar, N-O-R-S-T-R, or like Norstar, out of Stony Creek, I believe. We're not necessarily tied to one window manufacturer either. If you have a particular window manufacturer that you say, hey, we'd really like to use his windows, we'd work together with that supplier to come up with details that work. For the first two, we'd probably like to use this window manufacturer because we've worked through some of those details. But we're open to, if you have a particular window that you'd like to use, we'd be willing to do that. So very exciting. We've had a lot of customers since then ask for the windows installed. And the nice thing is winter heat too, right? So as you're starting to build in the winter months and you got to pump heat in to heat the hollow core, you've already got, there's no tarping to do because you got your precast walls up, you've got your punch windows installed. If you have a little bit of glazing areas, you have to tarp that off. Other than that, it's turn the heaters on, grab the hollow core, and go. You don't have to worry about snow coming in the building, etc., and having to remove all that snow again. So some more advantages, in-house service start to finish. So Total Precast end up being a bit more of a design build approach. So we work very close with the engineer and the architect and the owner to come up with the best precast design. Because no different than there's a cheap way or an efficient way to build a steel building or a wood stud building or a concrete building, there's also an efficient way to build a precast building. So we'll normally price off very concept drawings from an architect. We'll come out with about a rough layout. We'll get an engineer to review it. And then from there, we'll submit a proposal. The owner will say, hey, makes sense. We'd like to continue to go down this road. Then we sit together with the design team to keep working through the details to make sure that we're keeping that building as lean as possible for the owner. So all the engineering and drafting is done in-house. So we work with Tekla. It's a 3D drafting program. So we're set up to do BIM along with the architect and engineer if they're ready to do that. So everything's done in a 3D model. From here, we send that out to get approved by the architect, engineer, mechanical trades, etc. And then we issue our individual piece tickets off of this model. So every wall panel, every floor piece, every beam, every column, every stair landing has to get an individual drawing after this. And through our 3D program, we can do that. And then that's what gets sent out to the shop floor. So the guys actually in the shop don't see this building. They're working off of individual piece tickets, similar to steel fabrication. Right? So we do all the in-house drafting, engineering. It's all our own non-union install crews. At the end of the day, we have a reputation riding on these buildings as well. So we work with one developer where he installs his own walls, but for the rest, we'll install all our own precast. And there's the... I'm going to hold that question because I got a slide that kind of goes over some of that, yeah? If that works. And just some more advantages of Total Precast. So it's a durable wall that can be left exposed, and especially on the exterior or inside your stair shafts, you don't have to worry about drywalling and studding any of your stair shafts. It's already a concrete finish. Elevator shafts, etc. If we have an elevator or stair shaft on the outside of the building, we'll actually do an insulated wall on wherever it hits the exterior, so that way you still get the concrete finish inside and out. So you don't have to worry about getting damage in your stairwells. Sustainable completion in less work, a substantial completion in less working days. So that hotel, for an example, it's kind of funny. We're doing 2 hotels in the same town. So the other one's a block hotel or block walls and hollow core floors. It's been going for a year and a bit, and it's probably just as far as the Total Precast one we started in August. So definitely a savings in time. Building can be enclosed quicker, we talked about that. Superior fire resistance and acoustical control. So some feedback we're getting from the industry is it's cheaper to insure because it's a sound, concrete, non-combustible building. The acoustical floors, I think we get an STC of 51 on the floors, and then the walls are 60, I think.
56 and up, depending on thickness.
Yeah. Based on your thickness. So definitely high sound. So we actually have one developer. So normally when we build a building, we try to lean out the amount of shear walls because the less shear walls you have, the better cost per square foot we can give you. We have one owner that says, you know what, I just want a quiet building. My only quiet suites are the ones that have precast on both sides. So I'd rather just pay a little bit more to get that quiet building. So next we're just going to go through a bunch of design tips and challenges. Just kind of go through some of the different ways and the good and the bad and the pros and the cons. So engineering scope. A big thing with the Total Precast building is our engineer ends up doing probably 90% of the engineering work on that project. So with the total precast engineer, what we look for from the engineer of record is they create a structural drawing for the permit application or the initial permit application, basically just basic floor plans that says see precast drawings. We expect them to provide us the design load. So this is the seismic load, this is the wind load, this is the area loads that we want you to design to. Design the foundations. So from there, we'll build the actual model in ETABS or a similar program. And then from that model, we'll make the building work, and then we'll split the forces that are going to come down to the foundations back to the engineer of record, and then he designs the foundations of the building. Structural coordination and shop drawing review of non-precast elements. So they'd still be responsible for detail for window, any structural concerns in regards to window drawings or anything outside of the building, canopies, that type of thing. We would just focus on the actual precast components and the main structure of the building. So our precast engineers, so they'll design the precast superstructure based on the load provided. Once we do the overall model, get the overall model approved, they'll do the engineering on the individual walls. So they'll take their overall model and say, okay, this wall needs this much rebar, this wall needs this much rebar. Here's the different precast connections we need to carry it from floor to floor, which we'll go over what they look like in a minute. So basically you should see a fair big reduction in your engineer of record scope compared to if it was like a cast in place building or a building where they're responsible for more engineering. So any questions on this? There's usually a lot of questions on this one, but go ahead.
Yeah, it's interesting to see you can do everything basically. But when you do design and you install,
yeah,
so there is a little bit of lack of independence.
So that's why we still, yeah. So we still require the engineer of record to review our drawings. So they would be the owner's representation, I would say, in regards to yes, what they've done seems feasible here.
So owner should still hire its own engineer, or?
Yeah. So the owner would hire the engineer of record still. So that we would hire the precast engineer.
Oh, so
the engineer of record, this scope here is hired by the owner.
Oh, okay. I thought it was all part of your service.
Yeah.
But it is the.
Yeah.
Oh, okay.
But the engineer of record is signing off on your engineer drawings?
No, they're signing off on the overall building. We're signing off on our drawings. Yeah. Yeah. Go ahead.
So would you guys be able to lead the engineering record?
Yeah, so we've had this question a fair bit just because that scope has been reduced a lot. We've started to offer an engineer of record, but we make sure it's either an independent firm that we hire to help out as part of that package, or it's a separate engineer in our office that's going to do the engineer of record, so we have a double check in the background. So we'd still split the scopes, but we just split them internally. So.
What about below-grade parking?
So below grade parking, we can do precast down as well. Really what it comes down to is lot lines. So if you have 0 lot lines, there's no way for us to do precast around the exterior and then waterproof it. So if you have 0 lot lines and you're doing shoring, we'd recommend pouring the exterior wall. If you've got a big open site, like a hotel for an example, in a rural setting, then we can do the foundation walls. And we've worked with companies like WR Meadows, Tremco to come up with waterproofing details for the foundations. And in that case, the engineer of record would just have to design the footings. So just some different layouts and different ways that we see buildings. So this is probably the most efficient way to lay out a building. So this is shear wall style. So we'll basically have shear walls every 28 to 38 feet. We'll go over kind of why we'd pick those dimensions in a minute. So basically we'll have shear walls, and then we'll have a couple shear walls in the opposite direction just to stabilize the building. But the main load bearing is from suite wall to suite wall. And then we'll just throw an angle over the corridor. And then we'll have shafts to help take some of the shear. And then we might add a wall like this in to help distribute that load again. It's easier maybe to see on this picture here. You can see all the hollow cores spanning from shear wall to shear wall. This design actually works better for balconies. I guess it depends on what you're looking for out of your balconies. But with this design, we can come up with better balcony details, which will kind of explain the different balcony options. That's usually a big question too, is how do we get some balconies out there without putting the walls all the way around them? We've got some ways to work around some of that stuff. So this would be our first pick, so we always try to make this layout work first. If we can't make this layout work, we'll go to a exterior to corridor layout. So basically we'll make the exterior wall load bearing and then the interior wall. The reason we wouldn't pick this is from the thermal side, usually too as well. So with the shear wall to shear wall, your only thermal bridging is along these walls here. We can provide a 2-inch gap along the two long sides of the building, where we can bring spray foam up beside the hollow core, so you're not getting a thermal bridge there. These still would have some thermal bridging.
You provide insulated?
So we can do insulated walls. Insulated walls get fairly bulky, so we can do, so it's a 3-inch face mix, so that's your exterior finish. And then we can do 4 inches of foam, and then we can do a backer behind that, so it would be anywhere from 6 to 12 inches depending on the height of the building. So now you're dealing with a wall that's 7 inches for sure, plus whatever that backer, so 13 to 19 inches thick, so it's a big wall.
Which are our value?
So different insulations, so to be safe, R5 per inch, so R20. We have worked with a couple installations recently in our office. We tried out a new installation where we can get like R6.7 per inch. Yeah, and depending what you can get out of the concrete as well, right? Because you have good thermal mass there with the concrete, right? So this layout would work good if you want to put balconies out with columns. So then you just have 2 columns and you can use this wall to bear your balcony on as well. So that's when, depending on your balcony style, this might be an okay layout. And just certain buildings, if you can't get your suites to line up within your building, then you want to switch to this one, because trying to get a suite to the walls to fall in between your suites gets really tricky from a layout perspective. So that's when we'd start to look at this. You can kind of see here. This is a job we did on Jackson Street in Hamilton. Well, it's between Jackson and Maine. Right off the 403. So load-bearing wall, load-bearing interior wall, and then exterior. So this is a bit of a hybrid. So we'll look at this as well, where basically most of the building in this case was exterior to corridor, but on the ends we flipped it exterior back to the shear wall. So now what the benefit of this design is, we actually have lots of structural walls in both directions. So we have this big long plane here, as well as the plane this way. So stability of the building gets a lot easier from an engineering standpoint. The more walls you can have in both directions without adding cost, the easier it is to stabilize the building for us. But it depends how you want to step the building in up above too. So if you want to step it in like 6 feet at a time on the ends of the building, then it's easier to do the corridor to interior wall. If you want to step it in one suite at a time, then the suite wall works better. Or if you want to step in on the long sides of the building, then the suite wall works better again. Right. So Precast has a lot of advantages, but to be fair, it's got a couple of disadvantages. With Precast, we really need those line loads to transfer down to the foundations. So with cast in place works as a two-way slab. So you can take a wall here and then split it off and then put your rest of your walls here. Precast really needs to be a linear load pattern. Now we can do transfer beams, that type of stuff with the Precast. And recently we've actually started to use wall beams, which work really well in the hotel in Brantford. So let's say you wanted an open area on ground floor here for a lobby or whatever. We actually put a column in here and then we made this wall panel on this floor act as a wall beam. So there was no beam down below your ceiling and no extra cost. This wall got a little thicker. I think we had to go 2 inches thicker. So instead of an 8-inch wall, it was a 10-inch wall. But this wall acts as a beam to carry the walls above. But we can't do every wall like that. We need to have a certain percentage of the walls coming down to help stabilize the building. But really key that those line loads come down. The other thing we've been starting to do a lot is, because speed means a lot on site. So with other building systems, so if you're not ready to make that jump to the total precast system, we've been doing precast elevator and stair shaft walls. So whether it be a conventional steel reinforced building or a steel stud bearing, we'll do the shafts, which would normally be block or poured. We've switched them over to precast. Our recommendation is bring the precast in a bit early if you're going to do that. So this design does work, but sometimes it'd be cheaper to add in, to change one of these walls to a precast wall to help just distribute the load versus trying to put all that load back into this shaft. So with precast, you always have joints at your corners. With cast in place, that's a monolithic pour if you're pouring it as a shaft. That's it's a weaker connection there. So it might make more sense, instead of making this low bearing stud, just make it another additional wall of precast and your cost doesn't stay the same. Because what drives our cost is labor. So if we have to take all that force and put it through these walls, our connections are going to be very heavy. We're going to have a lot of reinforcing in that wall. It's going to end up taking us twice as long to produce that wall. But we might as well just switched out a couple more steel stud walls and then got more precast walls. So you got the savings of the steel stud, but your precast cost wouldn't have went up. So we do a lot of this lately again. You can kind of see here. More on the low-rise stuff. But. So here's where we answer the span optimization question. So we have 4 different thicknesses of hollow core. So the best cost per square foot on the building we get is normally when we max out the span of the hollow core. So in a residential setting, and hallways, etc., we can do 8-inch hollow core, 27 to 28 feet. So from shear wall to shear wall, we can do 27 to 28 feet. That's basically, if you can make that span work, that's the best use of 8-inch hollow core. 10-inch hollow core, we can get 37 to 38 feet. And this is probably, out of these optimizations, this is probably the best. Because you've eliminated another shear wall every 10 feet, but your increase in hollow core cost wasn't that much. So the closer you can get 10-inch to work at 37, 38 feet, the better that helps your cost per square foot come down. 12-inch hollow core, 42 to 43 feet, and 14-inch hollow core, 47 to 48 feet. Typically, most of our buildings use the 8 to 10-inch hollow core. We've done the odd one with 12-inch hollow core, but sometimes the buildings will have an exterior parking garage around the outside of it, below grade. That's when we'll start to see some of the more of these spans, but with the parking garage, the length gets a little shorter because of the higher loads. But yeah, most of the buildings would be 8 to 10-inch hollow core. We'll go from there.
You get the most of your camber when you try to max the span out?
38-foot 10-inch actually has the best camber ratio. So what he means by camber is hollow core naturally has a camber. It's a pre-tension product. So when we pour it on the beds, we have a 200-foot long bed. We pre-tension the wires up. We pour the concrete over top. Each wire gets pulled to 30,000 PSI. Afterwards, we bring a saw once it's cured and we start to cut the flooring into pieces. When you cut it, because of the tension, it's actually trying to bow up. So the product actually jumps off the bed by an inch, inch and a half in the center. What that does is basically all your planks come with a crown. So we install them that way. But then on site afterwards, once you do your steel started partitions, we come along with a skim coat and we flood each room individually to a 1/4 inch and 10 feet spec, so right to the flooring spec. But that basically levels out your floors. But to answer your question, the 38-foot span, because you have enough mass in the center, it actually starts to bring down the camber. It's actually worse if you go a bit shorter. But
Your shear walls then?
Yep.
Typical 2 or 3 story building? Are they 8, 10? They vary?
So they'll change as you go up the building. So I would say, just a real rough rule of thumb, 0 to 6 stories, you'd be 8-inch walls. If you want to do 10 stories, you probably got to add 4 stories of 10-inch walls below. If you're going up higher than that, maybe another couple floors of 10-inch, and then probably some 12-inch down at the bottom. So it depends on the building and how many walls you have in the building too. We've done jobs where they're 8-inch. We just Phillip Street in Waterloo. It's 8-inch walls it's 22 stories. It's 8-inch walls from the top floor right down to the ground.
I was thinking of your span there, obviously efficient parking. So
Yeah.
low grade with that 3.7 minimum.
Yeah.
Center to center.
Yeah. Yeah, so I think most parking is 9 feet, right? So yeah, 36 feet forward, and then you get enough room you got 2 feet to play with, essentially. So. Any other questions on span optimization? I'm going to pass her off to Sean and get the real presenter up here.
Oh, setting the bar high. So that's span optimization, but we're going to talk about wall panel optimization. So what does that mean? What's wall panel optimization? Basically, it's the square footage of one particular panel. These projects are driven by economics, so people want to save money. So our advice to you with wall panel optimization is try to create bigger wall panels. So you see one panel here has a larger square footage than these strips. These strips are architecturally pleasing, but they're a lot more money per square foot. So what we try to do when we come into these buildings is we ask if maybe we can add a little bit of precast across the top to create a bigger panel, because that way we can spread the labor to form this panel over a bigger area, which is going to reduce the cost of your panel. So things to consider when you're laying out your building is how big can I make these exterior walls, and can I hang them off my shear walls that Jason was mentioning earlier. So in a load-bearing condition, that's a little different, but in a non-load-bearing condition, it's really nice to stretch those cladding walls and get them as big as possible, because then we can reduce that rate per square foot, which is going to save you money overall.
Can you say it again, between load bearing and non-load?
So if you wait 1 second, I'm going to jump to the next slide. You can see the difference. So there's a couple different rules in load-bearing compared to non-load-bearing. But ideally, in your non-load-bearing walls, which you see a lot of these ones here, try to stretch that square footage out as much as you can, because we're going to hang it off suite walls, and then we can reduce that cost a lot less. Sorry, you had a question as well?
So what's the optimal, I guess, wall length?
The optimal...
Sometimes if it gets bigger, you need bigger frames.
Yeah, absolutely. That's a great question. So shipping is our biggest governing factor. So I would say 40 by 13. That's your biggest dimension. Otherwise, we can't ship it down the road. But another thing you want to watch is your weight, like you mentioned with the crane. So a good rule of thumb is design for 22,000 pounds all the way around the building. But sometimes you'll have conditions where that's higher. But that's where we're going to join the team, and we're going to work with you to try to find solutions to bring those weights down. But the answer to your question is ideally, it really depends on that span of your suite walls. So Jason mentioned earlier about 38 feet, then ideally make that cladding wall 38 feet so we can hang it off those two. If those are shorter, then you're obviously down to 27, 28.
What about your opening to ratio for load bearing and non-load bearing?
Perfect. Great segue. So we're going to jump to the next slide right here. So this is your load bearing wall. Thank you very much. What you want to do here is you want to ensure that you have enough meat up here with no openings or penetrations. And what that ledge does right there is that picks up the hollow core. So you're going to picture an L. That hollow core is going to bear in that top ledge. So you want to make sure that you don't have any openings in there so that we have that clearance and enough room for steel underneath to support that hollow core span. So a good rule of thumb is about a 300 mil header above here without any interference. But you're going to ask probably about mechanical openings and vent openings. What do we do with those? Ideally, sometimes we can put them in here, but as you get lower in the building, you're going to get more steel in that panel to handle that load that you were talking about earlier. So sometimes what we'll do is we'll say drop that header a little bit lower, about a 500 mil. Give me a 150 mil above, a 150 mil below, and I can give you a 200 box in there, and that's your opening. So there's a couple different ways you can play with your vent openings, but the one thing with load-bearing walls you really need to remember is almost treat it like a beam underneath there to pick up that hollow core span. Make sure you got some meat there that has no interference, no openings, no fancy casting materials. And that's your load-bearing condition. When you get to a non-load-bearing condition, you can tighten that up a bit. You don't need as big of a gap. The key number right there is the 275 mil. And with that 275, what we're doing is we're running a strand all the way across this panel, across that top, that's going to hang off those two suite walls. So I need to make sure that I have a linear line all the way across at 275 where I can run that strand. So if you're going to put your vent openings, put them above, leave me 275. Or if you want to bring them down and put them right above the opening, just give me 275 above that opening. So either way, continuous 275 across the top allows me to run strand. And then down below, we need a little bit of meat as well, but sometimes we have some tricks here where we can eliminate that. What you have here is you don't have near as much steel in these panels. They're a lot less load on them, obviously, because they're not load bearing. So it's just you mostly strand a little bit of conventional reinforcement. So we can charge a lot less for these walls. So getting to that point, again, stretch these out, get them as big as possible. Be cautious where you put your vent openings. And punch windows. Everybody loves glazing, curtain walls. We really push the punch window. We can guarantee your openings, so you can order your windows ahead of time. But we definitely have solutions if you want curtain walls too. But a lot of times we try to push these into punch windows so we can get bigger panels to avoid those strips of cladding you saw before.
What's your minimum panel thickness then? Must be reduced from the load bearing?
Yeah, great question. So 6 inches is our minimum thickness. We've had a couple of unique scenarios where we went to 5, but ideally we'd like to stay at 6.
What if we want to do an inch or two reveal?
Perfect. So if it's an inch or two reveal is just going to get added to that 6-inch thickness. So assume 6 inches is always what you need. And then if you want to do like a recess, which we'll talk about real soon, actually the next slide, is in this scenario here where you have a recess, say you want to run this glazing all the way up here. You kind of want that floor-to-floor look of a curtain wall. So this is a general rule of thumb. We'll say load-bearing wall is 10 inches, and non-load-bearing wall is 6 inches. And then you want to add glazing reveal. Just add the 2 inches to those thicknesses. So my 10-inch wall now becomes a 12-inch wall. My 6-inch wall now becomes an 8-inch wall. And what that does is it allows us to step in a recess where that glazing is going to pass, floor to floor continuously through. But if it's a load-bearing wall, we've got the support we need to support the hollow core. And if it's a non-load-bearing wall, we've got the 6 inches we need just for that mass. So there's a couple different examples on these buildings where you've seen they've leave that gap there. So this scenario is actually a load-bearing wall. So that's picking up the hollow core span, but it's allowed them to run a curtain wall window all the way up the elevation. So we've got another scenario too, same idea. They've just kind of doubled up their window, but they've made that wall 8 inches, but that mass behind is actually 6 inches, and then allows them to run the double window up. Same theory will apply if you want a full curtain wall too. We can do the same step in and give you that bigger area. The crucial thing is that I really should step back a bit is just make sure you leave enough meat on the sides too. Don't completely eliminate that because I'm going to have a bit of steel there. And in a load-bearing condition, it's a little bit thicker. So any questions on the load-bearing and non-load-bearing walls? Perfect. So wall assemblies. This is a big one. As Jason mentioned.
Just back up.
Yeah, sorry.
I'll call it window wall, but it's not a curtain wall, I'm sure. So your frame in that situation to run past is pretty much almost at the exterior of the panel. It's not really recessed too much.
Sorry, I don't quite understand your question.
Well, if you're running, if you're talking about a window wall system running past, and you only have that, you know, we're doing it. We're actually setting the slab back and running it through.
Yep.
Where you're doing a little 2-inch recess and then running the system through.
Correct. So you
Spandrel panel or aluminum cap or whatever it's going to be.
for sure, and it's going to be flush with that exterior precast face.
Flush with the exterior.
Yeah.
So you want as much depth there.
But we could, if you needed more depth, we would just increase that panel thickness, right, to give you the depth you require. Say you need a 3-inch or 4-inch. I don't think we've done any where they protruded out, right? It's always been flush with the exterior elevation.
This has been the odd one where they're recessed a bit.
So wall assembly, so Jason mentioned earlier joints. Joints is the big thing. Precast joints is probably our biggest weakness. We got a lot of advantages and benefits, but we do understand that there's more joints in a precast building than a cast-in-place building. So what we've done is we've gone in with 3 third-party companies like EXP and some other testing companies. We've come up with some details, and what we're providing is a 2-stage caulking joint horizontally and vertically. You're going to have a 3/4 of an inch joint vertically and a 1-inch joint horizontally. What we're doing is we're essentially putting the first bead in that panel a little bit recessed, then you're going to do your backer rod, then you're going to do your face bead. And what that does is you can see here in a load-bearing scenario, it returns at every level out to the exterior. So that basically if any water gets in there, it's going to return out on a level per level basis. This first layer of caulking is there to last about 10 to 15 years, but if it fails, we have a secondary system that'll drain. This is very important. We don't want any water in the building. Obviously, nobody wants water in their building. So we've really done our due diligence to ensure that these joints are being treated properly. Also, our thickness of our panel is acting as a rain screen as well. So if you have 4 inches or greater of thickness of concrete, it is non-permeable, which is recognized by OAA. So that's actually wicking away some of the water as well. And on the inside of the panel, what you want to do is you want to leave, our preference, I mean, there's ultimately different details you can use, but our most common one would be to leave an airspace, then use your stud track, and then spray foam against that exterior precast wall. But it gives you room to run all your mechanical, electrical surfaces up. It's a bit of a cavity to play with, but then you get your air and vapor barrier there on the exterior wall.
Aren't we still having a problem with Pro-Demini giving us insurance for total precast system?
Not to my understanding. I think that there's some third-party companies that have looked at different ways to drain some of these precast panels and to deal with the rain screen principles.
I think that's something maybe you should talk to them about, because my understanding is quite recently that we can't get insurance for total precast.
I believe there has been some conversation about that, but there's some third-party companies that are looking into that. CPCI as well as a big governing board. So I believe they've investigated into that to make sure that the understanding of the insurance's understanding of how it's working compared to how the precast is working is on the same page. So I don't know enough about that, so I can look into that for sure and maybe get you a little bit more clarity. I'll leave you my card. To my understanding, I think that CPCI is taking care of that right now, and they're looking into that to see if they can find a solution.
We're looking at some precast now. It's pretty important for us in our conversation with the owner to say, we can't get insurance because we're third-party insured, and that's going to cost him money. So it's a big concern.
Well, for sure.
The only difference is the details we're using are the exact same details being used on the architectural precast downtown Toronto since the 1960s, right? So some of these details, the details that we use come right out of the OAA handbook. And there are details that are being used on all, you see a lot of architectural precast in Toronto. It's the same details that we've used on this system. It's a valid point. I'll look into it, but
I'm not sure of the difference between exterior precast panels and total precast. I think that's where there's a difference with programming. So I'm not clear on it myself.
Okay, we'll look into that.
I had a letter saying,
Yeah, for sure. We can get you some feedback on that. We do know CPCI is looking into it for sure, because obviously that's a big issue to them too. But with that, does anybody have any more questions with the load-bearing exterior wall assembly? Because we're going to jump to the non-load-bearing next. So in a non-load-bearing condition, what you're going to do is a very similar detail on the exterior wall with the two-stage joint horizontally and vertically. But there's a gap here. So the precast is actually bearing on the wall in a load-bearing condition, but in a non-load-bearing condition, it isn't. So you're going to have a bit of a gap here. And what we recommend is to stuff that with a rock sol or a fireproofing material and then a fire-stopping caulking there. And what that'll do is give you your continuous insulation floor to floor, as well as that fire rating that you need on a floor to floor as well. So these are the two ways we are currently dealing with joint sealing with exterior cladding walls and exterior load-bearing walls. There are other options available. We find this is the most common and has the most testing and third-party analysis on our end. So we talked about insulated walls before as well. Jason kind of went over the assembly of the insulated wall, but I'm going to talk about the applications of the insulated wall. So exterior stairwells is a big one. You want a durable wall, concrete exterior and interior. Not many people drywall their stairwells, obviously. Mechanical penthouse is another one where you've got equipment up there. It's sometimes a moist environment or a wetter environment, so they like to have the concrete on the interior side as well. Another application we're seeing a lot of is with the parking garages. If they're heated and unheated spaces in the lower levels, they're actually adding insulated walls in certain sections too. So maybe the locker room's heated, but the outside area isn't. So instead of doing stud and insulation down there, they just opt for the insulated precast wall instead. We don't do the entire buildings yet. A lot of people ask that question, why don't you just do the whole exterior? It's, like Jason mentioned, the wall thickness and the cost. It's more economical to use that previous detail we just showed than to try to do your whole exterior assembly with insulated walls.
do you have an approximate cost differential between them?
I don't actually. I don't know. We ran a couple of scenarios to the owner, and do you have a number?
I would say $5 a square foot.
So a lot of times we give an option A and option B, insulated or non-insulated.
Horizontal,
In addition.
in addition.
Yeah. Plus your foundations are going to get bigger. Everything's going to get bigger based on that bigger wall assembly too, right? So there's other snowball costs that maybe aren't calculated in just that snapshot of the insulated wall itself. So we're talking about wall connections. So we got a lot of different wall connections, but we're going to show you the most common ones that we have. The most common structural connection we deal with is a grout tube connection. And what that is basically, here's your structural wall. It has a splicer bar cast in. What we're going to do is we're going to lay that hollow core onto that load-bearing wall. Then we're going to thread another bar in that's going to be sticking up into the air, about 3 to 4 feet, depending on the development length of the bar. Then the next panel is going to come to site, and it's going to have this tube cast into it. And what we're going to do is we're going to fish that panel over top of that bar sticking up, make sure it's all leveled and aligned and braced. Then we're going to pump it full of high-strength grout, non-shrink grout. It's going to stay braced until that cures. We put the next floor on top and pull the braces off. This is your most common structural connection. Sometimes we get to lower levels, we need to add bigger welded connections just for some of the forces, but we ideally try to use this as much as we can. This grout tube is slightly oversized to make sure that that building doesn't creep away on you as you're going up. Gives us an ability to make minor adjustments as we're coming up. We're checking with the surveyor points. We run little crosshairs underneath to make sure we stay level all the way up. Because you may not notice it, but it'll start walking away on you if you're not careful. So it's very crucial to make sure that you keep these nice and aligned, and having that adjustment in that grout tube allows us to do that. Now, between panels, so that connection we just saw was an up and down scenario, and side to side, we have alignment connections. So again, in lower levels, sometimes welded due to the forces, but we prefer a bolted connection when we can. 2 reasons. Anybody on the crew can go up and bolt into the wall. So it allows for minor adjustments in height as well. If you cast into plate, you got to make sure those are bang on. So that's the big one for sure. And 2 is just the number you need. So sometimes in a lower level, you might have a greater quantity of alignment plates between 2 panels, and as you get to the higher levels, maybe a little less. And then the exterior walls are hung off of what we call a knife connection in a non-load-bearing condition. So in a load-bearing condition, we're going to use that grout tube, but in a non-load-bearing condition, we're going to use a knife connection. And what that is you picture this as that suite wall sticking out, and it's going to have 2 plates cast into the top. And then we're going to physically come and we're going to lay these panels from suite wall to suite wall and drop it onto those plates as bearing points. And then they're going to have a little bit of an adjustment nut right here, just to make sure we get that alignment right this way as well. Make sure it's nice and level. That panel's not, torquing on you a little bit like that. Once that's set, it's welded, and then sometimes we'll even, at the top, we'll do a little bit of an alignment plate just to tie back into the hollow core just to give some stability as well. So any questions on the wall connections? Perfect. So we touched a little bit on balcony design. Balconies are typically a thermal nightmare. I'm not going to lie. So this is something that if you're real keen on thermal performance of your building, I would think this is the most important slide you're going to listen to all day. So what we prefer, if you're very thermal driven, is to use wing walls. And what those are walls that are on the exterior side of the wall that allow us to hang that balcony from wing wall to wing wall, but keep it off the exterior face of the building. That'll allow you to run that continuous insulation all the way up. You have a nice clean break. So this is definitely the most common balcony we would push in someone that's very, keen on thermal performance. But a lot of complaints they get is, yeah, that's great, but I got 2 walls right beside my balcony. So I turn and I look at a wall. And that's not aesthetically pleasing, especially if you had a great view that you wanted to take a look at, right? So what we do is we offer this option, which is basically a cantilevered arm that is sticking out of that interior wall, which you can see here that's sticking out. Still allow you to hang that balcony off that exterior face, so it'll bear there. There's still that gap coming up. Yes, you have a small thermal transfer through that arm, but you get a nice open view side to side. So my recommendation is if you're designing your balconies and you care a lot about thermal performance, option A, option B. Doesn't always work for your layout though, I'll be honest. Sometimes we're tweaking layouts and you don't always want to tweak the layout entirely based on the balconies. There's other efficiencies you're trying to find in the building as well. So if that's the case, you kind of start progressing into less performing balconies. This is another scenario where Jason mentioned before where you're actually going to bear part of that balcony on the exterior wall. So there's going to be a transfer from that balcony into that load-bearing hollow core, or load-bearing wall, from the balcony through the load-bearing wall into the interior hollow core. There's a slight transfer of thermal there. But you have this column on the outside, so you've got basically 1 to maybe 2 sides of transfer. The other sides are open. So this is another scenario where we see where, most common on a corridor exterior layout where they want to add balconies, this is typically what you get stuck with dealing with. Then the worst balcony you can do is this one right here. Everybody loves them, they look great, they're floating, that's exactly what I want. I'm going to tell you the truth. You're going to have horrible performance, and that solid, it has to come all the way into that suite and bear on the next load-bearing wall inside. That solid is 4 times as much as your conventional floor. So that balcony, sometimes these balconies are costing you thousands and thousands of dollars with that premium that you got to pay for that interior floor just to get that look of that floating balcony on the exterior. So my recommendation would be don't do this. This is your typical cast-in-place buildings, though. They're always going to have their cantilever balconies. Some people just are set on that look and they really want it. And that's fair. If that's something you're willing to accept, you can model your buildings, find other efficiencies in your buildings to meet your thermal requirements. That's totally fine, too. But a lot of times, structure and layout are just so much easier. And starting on a clean slate, keeping it easy, instead of doing fancy mechanical equipment, fancy additional items to meet your requirements, stick to the structure. So parking garages, we're just touching a little bit on parking garages. The big thing is load-bearing alignment like Jason touched on before, and that 38-foot span ideally. Yeah, go ahead. Yep. Yeah, sorry, good question. I should have mentioned that. So we are providing a slope, 2% slope. We're also going to put a drip edge on the underside, and I'm going to guarantee you that 2% slope. So a lot of times in cast-in-place buildings, you say you're getting a 2% slope. Are you actually? I don't know. You got to form that out and get that level right. Whereas we're forming ours on a bed, we're going to give you a true 2% slope, we're going to give you a drip edge, it's going to get a nice broom finish on the top so it's not slippery. So it's a finished product when it comes to site. The only thing you got to do is put on your railings or your glass guards, whatever you prefer.
So you can actually drop that if you want to a couple of inches down from the floor level.
Absolutely. Sometimes we'll put a curb on and then come down, or we'll do a flat and then a slope, or a gradual slope. We've got a couple different options for the balcony, but ideally, get that water away. That's what we're definitely trying to do. With parking garages, the big thing is just get the load-bearing walls above to line up with your parking spaces below. That doesn't always work, so there's other options, but that's where we start with. So try to adjust your suite walls to fall into parking spaces below. That's your best bet. If that doesn't work, option 2 we've done in a couple buildings is a transfer slab. So at your podium level, your tower has a different layout than your lower level. There's a nice transfer slab at that level, and then we change your parking layout. That's an option 2. And then option 3 in some of our buildings, they're actually pouring the parking garages, and then we're doing precast towers. So it's really a function of the design and layout. If the layout works, obviously it makes sense for me to do a precast parking garage. It's going to be quicker on site. But some of the constraints, or you're working on an existing site, or you're tying into an existing face, doesn't always allow that. So we do get hybrid buildings from time to time too, where they are cast in place the parking garages, and then we're doing a precast tower. But with those, sometimes we will do the exterior cladding as well, so it matches the tower look. Or sometimes we'll take some of the interior walls, so they bring some of their poured walls, and we'll add, some of those insulated walls, or maybe some feature walls in other areas they need. So it's a bit of a hybrid system sometimes.
Do you have details of that transition from a poured to your precast?
Yeah, unfortunately not on this slide, but we definitely have a couple. We've done in the past, and we're working on a couple others right now. So everyone's different. A lot of people have different designs. The most common way we've tried to approach it is to use precast solid slabs. So you've got your hollow core that Jason mentioned before, but then also your solid slabs. So we would lay all the solid slabs at that transfer level to almost act as formwork underneath, stick some bars up, then flood that level with concrete to, we'll say, any thickness from 500 to maybe a meter, depending on the design. And then set our alignment plates for our wall panels to set into, and away we go. But yeah, we have a couple details if you're interested, for sure, we could show you. Really though, with thermal, we can talk about all these balconies and all these fancy caulking details and all that stuff, but there's some big things that you need to consider when you're designing layout. Layout's a big one. That shear wall, or sweet wall to sweet wall layout, we call it, allows you to run that continuous insulation up the exterior face. That's your best bet. Your balcony support, like we talked about, how are you supporting these balconies? How much of that's bearing on the exterior wall? Try to eliminate that if you can, maybe. Interior stud wall placement. Don't put your stud walls right against the precast wall. Leave that airspace, or it's going to transfer that cold through that stud wall. And then size of windows and openings. We can do all these fancy details on the wall. We can get all the caulking right, but if you put a huge window in, that's going to let in a lot of heat and a lot of cold. So these are things to consider too. Maybe convert to a smaller punch window. We can guarantee those size openings and get your building built quicker.
I mean, you talked about putting the windows in first, but there you've got your thermal bridging right away, because you're not recessing your window into the insulated component of the wall center. So do you have something where you can actually frame up the back of the window on concrete?
Exactly, yeah.
Recess it?
Yeah, and then I think it's...
on the studs instead? Or?
So it's framed out on the back, and then there's an airspace that they spray foam.
So we'll leave a recess all the way around the perimeter, so the spray foam actually comes in and then lines up with the thermal plane of the window.
Okay.
That's a good question. So if you're really interested in thermal, there's the Thermal Guide Mean Exceeding Building Code Thermal Performance Requirements by RDH. I believe John Straub puts it on. He's an expert on this. I'm not. So if this is really your bread and butter and you'd like to learn more, great speaker, I'd highly recommend. I think you can download it, or he also does maybe a presentation or two per year. Highly recommend attending this if that's your thing. Does anybody have any questions on the design tips and challenges? We're going to show you a couple sample projects, but I think if you have any, nut and bolt type questions, now would be the best time to ask.
I'm assuming all this is on your website, or you have a little design guide?
Yeah, we do. This isn't on the website, but what I can do is I can give you my business card, give me your email address, and I'll send it to you. And that way you'd have the whole performance.
See how this window recess system works.
For sure. Well, I'll give you my business card, send me a quick email with some of the ideas you're looking for, and we'll gladly get back to you for sure. So let's talk about some of the sample projects then, if nobody else has any questions on that, and if any come up while looking. Oh, sorry.
Did you have a question, Matt, or no?
No, we're good. So we're going to go kind of from low-rise to high-rise in some of our sample projects, but what we have here is a project we did in Mississauga. This is a total precast project. Obviously, these are all total precast. This used our form liner. The cornices at the top you see there are actually precast as well. This is our first 4-story. We thought we were always in the market of 6-story and up. We were always pricing the lower story projects, but they never really came to fruition. And then once we found some efficiencies in our designs, we found a cheaper form liner, we put up our more automated plant, we've allowed to get those square foot costs down. Now this is an active market for us. I think we have about 5 or 6 projects that are in different stages of development in the 3 to 4-story range, and it just keeps growing. So that's a good sign. The floor plate does matter, so you need a decent square footage per floor for this to make sense. But sometimes even the small square footage ones make sense because your access is tight, and getting the precast projects or products in is a little bit easier than trying to form and pour and bring big equipment to site. But this was a good 4-story project we did in Mississauga, and the owner's really happy, and they're looking at a couple more options as well. In the past couple of years, hotels has really picked up for us as well too. They had a conventional system that had done for years and years and years. I'm sure all of you are familiar with how hotels are built. And they started to just kind of look at other options. And we did a couple with a pretty active owner that has a particular way of building systems, and he likes to really push that. So he tried and tried with the ownership group to get them to approve it. We went through some back and forth with details and how's the exterior going to look. We came to a solution, and they're really happy. They are building more and more hotels. Obviously, they're individually owned by private investors, but the brand company has a lot of say in how the buildings look, and we're getting a lot of positive feedback from the brands themselves saying these buildings look great. We'd like you to meet so-and-so. They build a lot too. They'd like to learn more as well. So it's good exposure. This one we did in Sarnia. It's got the form liner finish at the lower level, so when you're walking in the building, it looks a little more fancier, a little more premium. For the second level, they went to that flat panel we talked a bit about before. That's cheaper per square foot, so they save money overall. The big thing for them too was speed, like Jason mentioned. The sooner they can start renting out those rooms, the sooner the return on the investment. So ideally, Precast made a lot of sense when these started going up really quick and they could get those people in those rooms sooner. Yeah, go ahead.
Is the cost close to what a conventional would be? Where would you go?
That's a good question. I don't know the exact cost comparison. We've had a few people say it's a slight premium, but since they're going to hold it for so long, they prefer that concrete. So you're measuring, it's hard to measure that. How do you put a scale to that, right? Another thing too, like Jason mentioned, the insurance and the operating costs are lower as well with the concrete. So I would say on average, we might be a couple $100,000 more maybe per building. But there's those added advantages that they're gaining that's making them say, no, I'll pay that premium for that concrete building in lieu of your conventional system.
It's operational faster too, right?
Absolutely, right? So that can get eaten up pretty quick, that couple $100,000, right?
I have a question.
Yeah, go ahead.
More of an installation issue, but I've seen precast panels around, got chips or knockouts on the corner, and perhaps had some brick embossed on them, and it's impossible to repair. So how quick can you turn something like that around, or what's the warranty? How does that work?
Well, typically what we do is we have QC inspectors in our facility, so nothing will leave the factory that couldn't be patched or repaired to our standards. And then if something happened on site, we have a great patching team that's very capable of, you would think crazy blemishes can be repaired to very aesthetically pleasing. But if you were to actually have to physically pull a panel off and replace it, we could turn that around pretty quick because all the engineering is done, all the cut sheets are done, all the piece tickets are done. So if the guys did get to site, as it was going up, it got nicked real bad, they're saying, you know what, I can't repair that.
It's not like a progressive install. You could pull it.
We could pull it out. My only concern would be if we were up a couple stories and then some other impact had hit one of our panels. That's a problem because then now it's like Lego. You got to tear it all the way back down to build it back up. I haven't had a case in the 7 years I've been here where we've had something like that. It's typically been a patch and repair job can take place, or they'll catch it right away during install when they set that panel and say, that doesn't look good. Get it out, reject it, send it back, crush it, we'll get you a new one. We might pivot, so we might now go to the other side of the building and start laying those walls so that wall panel can come in a couple more days. But ideally, we go level to level, so you got to make sure all those panels are in before we do that next level.
And just to clarify an earlier point that was made, you're taking now on the install, the caulking, and the warranty of the concrete.
Correct,
I don't
correct.
think we're before.
We offered it. Some people prefer not to have it, to be honest. So we have offered it in the past as an option, but in the past couple of years, we've really pushed. We like to control it because of that. It's that whole assembly you want to guarantee is going to work, right? But there is some merit to in the past people having that broken out because you still need to caulk your windows, you still need to caulk your grills. So having one trade do all of that probably has some economical savings. But we like to say for us to warranty and guarantee that this building is going to be tight, it's going to work. Let us include that in our scope. We have professionals that have done a bunch of our buildings. They understand how they work. They understand our details. And I think that's a better approach.
And what's the warranty of
Third-party inspection.
Absolutely. We always prefer third-party inspection hired by the owner to come and ensure. We actually insist that you do a mock-up even on level 1. So everybody comes to say, let's do a mock-up. Let's approve that, sign off. I'm going to guarantee you're going to get that for the rest of the building. You're okay with it. Everybody's happy. And away we go. It went up pretty quick. And I believe that they sold this building out in one day. So they were happy to get that feedback. And we were happy to build this building for them too. We're going to step into some of the more architecturally, the fancier buildings I like to call them. They're a little bit more per square foot. It's not that, that flat panel all the time and the big square foot panels. But these owners are willing to pay a premium per square foot to get a particular look. So this project we did in Waterloo, I believe it's a condo/apartment mix. But what they did is they've got the strips that we told you to try to avoid. They've got a lot of glazing. They got some form liner on the lower levels there. It's a bit of a wood look. It's kind of hard to tell in this picture. But it goes to show you that they're not all big square boxes. You can get creative. You can add a lot of glazing and still have a total precast building. So this owner's done a few of these. Another one we did for them was in Waterloo. It's called the Hub, which was 2 stories of underground parking and then multiple multi-story towers around that site. So this was a very big project. I think we were on site for almost a year. Would that be safe to say? But it went really well for us. They were really happy with the building. They had a really demanding schedule. So we did our best to meet the demanding schedule, and it was quite the project for us. But it spun a lot of opportunities for people to see how big you can make these precast developments if you design it that way from day one. So by having everything line up with the parking below and really thinking about that total layout and how am I going to interact between these spaces, it was well designed. It was well thought out at the start to allow this to happen.
The stubs that come out to support the balconies, how does that? Where are they stubbing out from?
So that interior wall panel, and it's poured monolithically into that interior wall panel. So picture if you're in your suite, that's your interior wall and that's your exterior wall. An arm would stick out from that interior wall out to support that balcony. But it's all one piece, if that makes sense.
Actually, just thinking you could actually increase the height of that if you wanted to. It could be a whole floor.
You could, absolutely. But that's, you kind of get into that wing wall scenario that we showed before too, right? Is that what you mean? Sorry if I understand.
Well, if it's poured monolithically, then you could probably, I'm just thinking in detail, you could extend that out, like stagger 2-story elements coming up. It's not just has to be this one form.
Yep. Oh yeah, for sure.
How you want to do it.
Yep, for sure.
Or bring it up to balcony height, railing height, or whatever.
Yeah, you just got to watch head height of panel, right? So the most we can ship down the road is 13 feet tall, unless we start breaking them and rotating them. So if you're going to go floor to floor at 10 feet, the most you can go up would be about 3 feet, right?
That 13 by 40 is that crucial dimension you got to watch for sure. So we'll show you a couple more. Same owner again, just showing some of the fancier ways you can use precast buildings. Again, the cladding strips, lots of glazing elements, a lot of form liner, playing with some colors. It just shows you that they don't have to be bunkers or big boxes for sure. You can get creative with your designs. So another project we did, actually we won an award for this last year at the Ontario Construction Awards. It had a lot of neat architectural features as well. Again, a lot of glazing, a lot of precast strips, but the interior is all load-bearing precast. The full package was done by us, walk away, and then the glazing crew comes in and finishes the project. Another project we did in Barrie, this was one of the very first total precast projects we did that actually has a transfer slab where the lower levels is all actually parking here. These are fake windows, so we have a 2-inch recess here, and then they just put in a fake window to give it a look, but there's actually concrete behind it because there's a bunch of parking there, so the cars can't go through the window, right? And then these low-bearing walls above didn't align with that parking garage, so what we did is we actually did a transfer slab at the roof using those solid precast slabs like we mentioned before, casting the deck, and then doing the towers above. Every one of these balconies actually has a view of the lake. This is in Barrie. So it made sense. It made sense to pay for that transfer slab, which is the premium from the units they would get for the lake view. So there's certain times where certain factors will make sense to pay a premium, and this was one of them for sure. Another project we did in Guelph, so it's got a bit of a brick veneer, stone veneer on the lower level, but above is actually all precast, but they did a really good job of matching the tones and colors to make it look consistent all the way through. Same thing here, they've got the wing walls on the balconies, they got a nice thermal break, so they did a good job of designing this building to perform well thermally. This owner holds their buildings for a long time, so it's important that they get good performance. And then lastly is the project we did in Phillip Street that Jason mentioned as well, that had the 8-inch walls all the way up. We've done 2 towers on this site, student res, and we're currently in the works on the 3rd. So that's it. Thanks for attending our seminar, and any questions for sure, go ahead.
Yes, so you're saying like from day one we have to do some good planning and this and that. Obviously we're not the experts and we don't, we want to work with you. In the preliminary stage, then can we ask some design consultation?
Absolutely.
Without, committal.
Yeah, so
we're asking some committal, but we as an architect, we can't just say, you will get the job.
absolutely, absolutely.
So how we can plan like bringing you in the design stage?
I think that's just it right there. So when you're thinking about doing a precast building, call myself or Jason. That is our job. So we'll come meet with you. Say my best advice to you would be get us in when you're still in the conceptual stages of the architectural drawings before any permits have went into place, because once you start setting that stuff, it's harder to change, right? So we'll come meet with you. We'll look over your drawing set. Maybe we'll take it back to the office for a couple of days. We'll do a markup. Say, can you move this wall? Can we change this? Can we move this? This will cost you less money. You may say, no, I need that. I want that look. Okay, that's fine. We just want to give you some options. There's a bit of back and forth. Maybe we'll tweak some layouts. We'll always come meet with you, kind of go over any questions or concerns you have, offer you all of our typical details, all of our little tricks and trades we're talking about here, and get that to a point where you would be ready to go to the owner to say you could price this. Ideally, we're doing this to help you because we want the opportunity to get the job, but we also want to grow the industry. There's not a lot of guys doing this. It's kind of a new and up-and-coming thing. So we understand that you can't always make that commitment, but we hope that the value and the cost savings and all the tricks of the trade we're sharing along the way has some weight with the owner. And then lastly, we hope we're actually the cheaper price too. When it does go to tender, we want to be the economical option and we want to be the expert. So there's no contractual agreement at that stage.
Oh, so we can expect some, a free,
helpful guidance. Yeah. But I'm sure architects get stuck in those scenarios too, where some people lean on you for a little bit of help, and we're not that type where we're going to charge you for that type of consultation. But it'll get to a point where if we need to start going to engineers to say how thick are my walls going to be, that gets to a point where it's say, okay, I need to go now hire a third-party engineer. I might need a small money amount, say 5 or 10 grand, for them to do a full analysis, to design everything, come back to me. But it's not going to be a full contract at that time. But there gets to times where, no different than having to go to an engineer yourself to get some advice that might come at a cost. So we're very open and upfront. We'll never try to trick you. We'll say there's no cost. This will help you. We got to go to an engineer. It's going to be X dollars. Is that okay with the owner? Very open book in that case. Does that answer your question? Perfect. Yeah, no problem. Any other questions? Perfect. Well, thanks. I believe they're going to mail your credits out. Again, we're at booth 5012. Yeah. So come see us if you have any other questions, and enjoy the show.